Hello viewers, my name remains Ajiboye Oladapo Jacob and I welcome you to the Global Tutor YouTube class. Don't forget to please like our channel, subscribe to our channel and share our videos. Thank you. We want to continue with what we started in my last video on mathematics. I started out with the topic set theory, and I said for us to understand the concept of set theory, we need to know the terms that are used in sets. We were able to discuss up to power sets in the last class, power sets, and I remember dropping a work to do for you. I said, if set A is A, B, C, I ask you to calculate the power sets, then I ask you to list the subsets. If you are able to do it, congratulations. For those that are unable to solve this, I will run through the solution quickly. Now, we said in our last class that power set equals 2 raised to the power n, where n is the cardinality of the set. So in this case, the cardinality of A is 3 because there are 3 elements collected in the set. Therefore, the power set will be 2 raised to the power 3. That will give me 2 times 2 times 2, which gives me 8. As simple as that. So the power set for this set is 8. Now, the next question now says you should list all the subsets. So the subsets are, empty set is always the first subset. Then you have A, you have B, you have C, you have AB, you have AC, you have BC, you have A, B, C. 1, 2, 3, 4, 5, 6, 7, 8. These are the subsets of the set A, and the power set is 8. If this is your answer, then congratulations to you. It means you followed through with what we studied in the last class. So today, we will look at some more terms and see how they apply. Now, the next term I want to look at is what we call finite sets. Now, what do we call finite sets? A finite set is a set with a definite number of elements. That is, you know the number of elements collected, you know the cardinality. For instance, if I give you set A, and I said A is 1 to 10, it is defined. So A is a finite set. So a finite set is a set whose cardinality is known. Then the next one is infinite. So you should know, by putting infinite, it will be the opposite of finite. So it means infinite set will be set with endless list of elements. That is, the list of the elements continues to infinity. For instance, if I give you x and I say the elements in x are 1, 2, 3, 4, 5, and I put 1, 2, 3, meaning this number continue to infinity. It can be to 1 million, 1 billion, 1 trillion. It continues. That is why you see the sign 1, 2, 3. So infinite contain endless list of elements. Finite contain a definite or a known number of elements. That is what finite and infinite sets. Now, the next time I will look at is equal sets. equal sets. Now, in mathematics, you already know the sign for equal to. That's the sign. Now, two or more sets are said to be equal if they contain the same elements. Let me give you an example. You have A, you have B. Set A is A, B, C, D, E. Then set B is E, A, C, D, B. Now, if you look closely, the elements that are in A are also in B the same. There are no difference. The only difference is the arrangement of the elements. Therefore, set A is equal to set B. Why? Because they contain the same elements. So we call it equal sets. Another term is called equivalent sets. Now, this is the symbol, 3 lines. Now, two or more sets are said to be equivalent if their cardinality is equal. Let's consider this. You have X. 1, 2, 3. You have Y. A, B, C. Now, if you look at it, the elements in X are not the elements in Y. But how many elements do we have in X? 1, 2, 3. How many elements do we have in Y? 1, 2, 3. It follows therefore that what? Set X is equivalent to set Y. Now, what can we conclude? We can conclude that what? All equal sets are equivalent. Because if you go back to this example, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They are equal and they are also equivalent. But not all equivalent sets are equal. In this case now, 1, 2, 3, 1, 2, 3, they are equal, they are equivalent, but they are not equal. That is equal set and that is equivalent set. So, infinite, finite, equal set, equivalent set. Let's go to another term. Let's go to another term. Now, the term I want to consider is called complement of sets. Now, you can symbolize this with a prime as an index, or you symbolize it by putting C as an index. Now, what do we call complement? Let me explain it with this example. You have a universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have set A. Set A is now 2, 4, 6, 8, 10. My question is now, find a complement. Now, complements of set are the list of elements that are present in the universal set but not in the set in question. I'll come again. Complements of a set are the list of elements present in the universal set but not in the set in question. So to solve this now, we're going to have what elements are in A are in the universal set but are not in A. So A complement becomes 1 is here, 1 is not here. 3, 5, 7, 9. So 1, 2, 3, 4, 5. These elements are in the universal set, but they are not in A. Therefore, they are the complement of A. So the complement of a set is the list of the elements present in the universal set, but not in that particular set. That's what we call complement of a set. Another term, union of sets. It has a symbol U, like this. Now, I will explain union of a set also with an example. I will explain union of a set also with an example. What do we call union of a set? Now, finding the union of a set means listing of the elements in all the sets in question without repeating any. Let's consider this. I have a set A. It gives A, B, C, D, E. Then I have a set B. Set B contains A, E, O. My question is now, find A union B. That's my question. Now, if the question asks you to find A union B, the examiner expects you to list the elements in A and the element in B without repeating any element. So, solution to this become A union B equals A, B, C, D, E. What's this? O. So you have listed the element in A and B and you did not repeat any. So when you do that, what you have done is you have looked for A union B. That is listing the element in A and B without repeating any. Let's go for another term, intersection. That one is denoted with the symbol N, intersection. Now, let's assume the question here is find A intersection B. Now, what intersection means is that you look for the element common to the set in question. You look for the element common to the set in question and you won't repeat it. So if we come down here, A intersection B becomes A, E, E. So A and E. That is the intersection between A and B. Intersection means the element common to the set in question and you won't repeat it. So there is A here, there is A here, there is E here, there is E here. So the intersection of A intersection B becomes A and E. That is the meaning of the term intersection of a set. Now, at this junction, I would like to show you how examiner occasionally presents question under complement, union, and intersection. You will see examiner oftentimes using inequality sign to present question. So I want to quickly tackle the inequality sign so that when you see them, you can interpret them. Remember, this is greater than, this is less than, this is greater than or equal to, this is less than or equal to. So in some question you can have A equals a set X such that 1 is less than or equal to X and X is less than or equal to 10. What this question implies is they will not ask you to list the element of A. What it implies is that A equals 1 is less than or equal to X, meaning 1 is equal to X. So you have 1, you have 2, you have 3, you have 4, you have 5, 6, 7, 8, 9. Now because they said X is less than or equal to 10, 10 is also qualified. But let's assume it was, let's say B, they now give you Y such that 1 is less than Y and Y is less than 10. It follows therefore that what? Your B will be 1 is less than Y, so you can't take 1, so you have 2, 3, 4, 5, 6, 7, 8, 9. You can't take 10 because Y is less than 10. So oftentimes you see the examiner using the inequality sign to present the elements of a set, but there is nothing to be confused about. Just know this is greater than, less than, greater than or equal to, less than or equal to. And I've shown you an example of how it is used. We are still going to consider question, so you will see more of that. The last term I want to take in this video is called disjoint sets. Disjoint sets. That's the last term I want to take in this video. Disjoint sets. Disjoint. Now, I will give you an example, then we can see what it means. I have set A. It has 1, 2, 3, 4, 5. I have set B. It has A, B, C, D. My question now is find A intersection B. Okay? Back to the formula, to the terms rather. Intersection means you list the elements common to the set in question. So I'll come here. There are no elements common to this. So it means that A intersection B is what? An empty set. Anytime the intersection between two or more sets is an empty set, the sets are set with disjoint. So it means set A and set B are disjoint. They don't have any elements in common, meaning the intersection between them is an empty set. Anytime the intersection between a set is an empty set, the term used for it in set theory is called disjoint set. I'd like to end the video here and continue in our next video. Thank you.